Hi everyone. So we are at the end of this particular session. This is the last session of the day, and this will be a session from one of our speaker who is an independent technical consultant and product architect with Dataware. In this talk, the speaker will talk about high-level steps that are essential for creating an effective pipeline for creating and deploying Docker in CD environment. So I would like to welcome Daniel Bryant on the stage.
Thank you, G. Great. Apologies, everyone. We had like some random technical issues there, so I was a bit like, So if I talk even faster than usual, I apologize. My brain is going 10 to the dozen there. But welcome. Thanks for sticking around. It's been an awesome conference, but I appreciate this is your last kind of session, so hopefully I'll do it well. I want to start by framing some of the things I hear around containers. Yeah, and this is not Docker per se, it's containers in general. Often the pitch is that everything is shiny. Yeah, we simply carve up our applications, we put them in containers, we ship them, and we are good to go. Yeah. Now, this sometimes works, particularly with greenfield projects, but the reality, particularly in the Java world, is we have quite a bit of legacy, or money-making software, as I like to say, yeah? And some of that legacy is a little bit of a tire fire, yeah? Now, I've written my fair share of tire fire apps, unintentionally, to be honest, but I've written my fair share, yeah? And when you put tire fire in a container, what you actually get is literally tire fire in a container, yeah? And you'll notice down here, the firefighters, this is what we refer to in our industry as DevOps, yeah? And this is how I make my money as a consultant, basically, in the UK, in Germany, and also in the US a little bit as well. And this is me, shameless self-promotion here, at Daniel Bryant on GitHub, Twitter, interwebs in general. I am an independent consultant. I'm also working with Datawire, based out of Boston in the US. If you're on Kubernetes and using things like Telepresence, Datawire steward Telepresence, Datawire wrote Telepresence. We've also got the Ambassador open source API gateway for Kubernetes, based on Envoy as well. So I do lots of work in that space. I've had quite a checkered history. My native programming language is very much Java. I do a bit of Go, a bit of JavaScript these days, a bit of TypeScript. And I've just written a book on Java with Abraham Marin-Perez. In a slight change to the advertisers, as Ajit mentioned there, I'm not going to walk through all the steps in detail, because I realized with 40 minutes that would be very challenging, yeah? So I'm going to pick on a few specific points that I and my teams have struggled with in various consulting gigs I've worked on. But the books do go into, there's a free one, courtesy of Nginx on the left there, the Containerizing Continuous Delivery in Java. The other one is a paid one. It's just been released, actually. Perfect time for Christmas. I'm sure your partner would love to learn about continuous delivery and Java, yeah? But, and the book will go into a lot more details. Hat tip to my co-author who couldn't be here, Abraham, did some fantastic work with me, and I thoroughly enjoyed working with him. So to set the scene, to kind of make sure everyone's on the same page here, continuous delivery in Docker. So continuous delivery is all about velocity and stability. It's what we generally prize in this industry. Yeah, we want to go fast, but we want to do it without falling over, and we don't want to get breached in terms of security. My friend in London, fantastic author, Steve Smith, had this great phrase that really resonated with me. Yeah, continuous delivery is achieved when stability and speed can satisfy business demand. Discontinuous delivery is occurred when stability and speed are insufficient for the business. What that basically says is your mileage may vary. I don't know your context, so for you, bash scripts might be fine to get stability and speed. They might not be. You might want to invest in more tech. But the point Steve's trying to make here, and something I really like, is continuous delivery has got, grown to be quite a big thing. But it's fundamentally about delivering value to customers, using software, and going fast, and not falling over, and not getting breached. That's the key thing, yeah? Typical kind of Java pipeline, just the level set here. Apologies if it's a little bit small, but I'll just run through briefly. You're coding on your local machine, yeah? Probably commit to GitHub or Bitbucket. Building in Jenkins, Circle CI, something like that. In the Java world, we push a Java artifact, typically a jar, a war or an ear. We push that to a repository. Then we do some QA, maybe some manual, maybe some automated. And we push through to staging, ultimately prod if the artifact meets our requirements, both functional requirements, business requirements, and cross-functional or non-functional requirements, yeah, as we often call them. Continuous delivery does not stop there. I often see this in gigs I work on. You must complete the loop. Continuous delivery is all about feedback and learning. Are we optimizing for our learning? Are we learning about our business? Are we getting feedback about our business? Are we getting feedback about our architecture, about the technology we're using? This is a vital, vital thing. And I'm not going to cover the observability kind of loop or the KPI loop today, but please do take this away as a continuous delivery does not end until the service is retired, until you undeploy your service. Yeah. So the good with Docker and Java, I'm a big fan of Docker, hence why I'm here, yeah? Docker all the things. Yeah, your dev environment, particularly in Java world, it can be quite verbose. You can wrap it all up in a nice manifest in a Docker file, or just ship it as an image. Docker enables repeatable builds, something I've struggled with, non-deterministic builds in the past. Loving my clone kind of reference there. I really do like that for Docker. And legacy tech and old frameworks, we can kind of hermetically seal them away. Yeah. Anyone, I'm actually on camera, I'll be careful what I say. I'll pick a random technology, WebSphere or something like that. Anyone who's running WebSphere will recognize really old versions of WebSphere, or really old versions of Tomcat, really old versions of anything. I don't want to install them on my machine. I want to containerize them, run them in a container, and then throw them away when I've kind of done with that. I might have to run it because of a business requirement in dev and test, but I don't want to install it on my machine. And Docker is fantastic for that. Some of the bad stuff I've done, or mistakes I've made, or I've learned from my team, yeah? So often the kind of pushback is this, why is this container image a gig? It's a hello world app, yeah? And often it's kind of like we're just putting too much in the container without realizing, yeah? Dinosaurs have completed their dev test loop deploy faster than I can, yeah? I'm like, really? But point is taken, big images take a long time to build, complex images take a long time to build. Things like Telepresence from DataWire, it's an open source project, do help with that dev test loop because we can actually proxy into the Kubernetes cluster. So I can debug locally running IntelliJ, coding on my Java, and I can route traffic from that cluster into my laptop and back through. So if you're on Kubernetes, check out Telepresence. It's really changed my kind of dev cycle. And I've also had a few, this Java app runs slow or freezes when I put it in Docker, yeah? And I've been there, I've made some mistakes. A lot of it is about configuration. I think the benefits of Docker for Java are amazing. You just need to make sure you recognize the technology limitations, often of the JVM, to be honest, into the Java spec. But you have to recognize limitations, code, and configure accordingly, yeah? So in terms of the impact of container tech on CI/CD, so we've got that pipeline I walked through earlier on, and I think it changes in these kind of 4 ways. Yeah, so from this to this. Number 1 is I'm going to have Docker desktop, or something like that on my machine to spin up some containers. If you're using containers, you've got to have something on your machine that deals with containers. I see some organizations which kind of hide Docker from developers and just have them coding on machines and shipping the artifact and then ops do all the containerization. I think that hiding that thing from developers is not a good call. It leads to a lack of mechanical sympathy. It leads to a lack of understanding that Docker can alter, in positive ways and other ways, the fabric we're deploying onto. Next, I think the way we now package artifacts is different. No longer am I shipping my jar, my war, my ear. I'm shipping a container image. Yeah? And I'm probably going to store that in a different kind of repository. The way I run my tests is subtly different. No more just spinning up a jar or deploying into Tomcat. I want to test the container because I want to make that, I want to bring production as close to my sort of left here as possible. Yeah? And then when we do get to production, you're going to need some kind of orchestration framework. Docker Swarm or Kubernetes, Mesos, take your pick on these kind of things. I'm not going to talk too much about number 4, to be honest, but the other ones we'll pick in. But do remember, all we're trying to do with continuous delivery is optimize for stability and speed. Yeah? Maximize your feedback, maximize your learning. That's the primary goals to keep in mind when building a CI/CD pipeline. Some lessons learned, mistakes I've made, I'll run through a few things which kind of I see a lot in consulting engagements. These are more enterprise-y skewed, but I do a bunch of startup stuff as well. First, we'll look a little bit at the local dev environment. First thing, regardless of containers, but definitely with containers, is make your dev environment as production-like as possible. Yeah. 2 things I see, as I've already mentioned, some enterprises want to hide Docker from developers. I do not think that is a good idea. There's a fair bit of stuff to learn, but it's that's part of our jobs as software developers. You've got to continually learn, yeah? And if you understand what you're working with, be it Docker, be it the latest version of Java, you will write better software. Yeah. I think spinning up stuff locally, doing tests in the container before you kind of commit is really essential. The second thing I see quite a bit is not using identical-based images from production. Developers get super excited with Docker, Ubuntu goes in, JDK goes into it. They announce success of the project a couple of months later to the ops team, and the ops team have a fit. Yeah, they're like, whoa, we don't run Ubuntu. We're licensed for CentOS in production. Oh, and we don't expose ports like that. Yeah, so you need not only to get the ops team, get the sysadmins involved from day zero. If you are bringing a Docker project in, get your whole team, end-to-end, dev, test, ops involved. But ask them, what are we running in production? Do we have Red Hat enterprise licenses? Are we running CentOS for the security reasons? These kind of things. Make the base images as similar as possible to in prod and dev. I'm not so exactly sure sort of the breakdown of the audience here, but one of the key things, and probably preaching to the converted a little bit, but the Dockerfile content is super, super important. And many enterprise companies I work with, if they're not so comfortable with Opsy side stuff, they've never written manifests before. They've never kind of had to think about operational concerns, and it's not their fault, it's just a reality of the situation, yeah? Suddenly they're bombarded with all this, like, I have to put an operating system in my binary? Previously I just shipped a jar and I was good to go. I have to think about OS configuration. How do I get the build artifact in there? And what about ports and volumes and so forth, yeah? And definitely, if you're looking at OS, Minimize, Alpine, or Distroless from Google is really good choices there, I think. We'll cover some of that stuff in security later. But then, looking at the Java stuff, yeah, do I put an Oracle or an OpenJDK in there? Do I have the JDK, the JRE, or even now we can use something called Jlink to create a statically compiled Java binary? Do I want to run Hotspot, which is the default, Eclipse OpenJ9, or Substrate VM, yeah? And I'm seeing though the default is pretty much Hotspot, I am seeing more and more people experiment with OpenJ9. It's got some really nice properties for short-lived containerized workloads. Being AOT, you can do ahead-of-time compilation as opposed to just-in-time compilation. Most of us in the Java world are comfortable with JIT. We know the Java, the JVM in particular, and the Java framework was optimized for 20 years ago, really. And it was you optimize for long-term running. So if the ramp-up of the app is a bit slow, no biggie, yeah? But when we're running containerized workloads that are coming up quickly and disappearing, we actually want to optimize for the startup time as well. And although JITting will give you the best performance, ahead-of-time compilation will give you the quickest startup time. So OpenJ9 is doing a lot of great work in this space. CDS and ACDS is basically class data sharing and application class data sharing, and that's basically caching your class files that are loaded into your app. So when the JVM starts up, it looks at all the class path and modules, loads them all into the JVM. You can actually save that out to a file, and the loading is much quicker the second time around, yeah? So all these things, they're all things that, as a Java developer, we've got to learn, or fundamentally, we've got to chat to the ops team and learn about all these new options and what they mean. And one of the key takeaways I'd like you to, I've mentioned a few times already, is please do talk to the sysadmin folks. If you're looking at bringing Docker in, looking at bringing Kubernetes in, I've learned a whole bunch of ops stuff over the years. I've kind of traded my dev knowledge with ops teams, and we've both learned from each other, and I've really enjoyed it. But not every developer does want to become operationally aware, yeah? So please do think about these kind of things. So start from a good foundation, yeah? I'm not going to labor this point too much because probably most of you are sort of familiar with these things, but the base image is super, super important in your Docker file, yeah? So a good start, bringing in OpenJDK, for example, we're adding our binary in and then we're running. It's a good start with OpenJDK 8. I'm going to do a little brief pitch that if you haven't heard, Oracle have altered their licensing model, their long-term support licensing model. So you have to pay for the Oracle JDK in certain scenarios, yeah? But Java itself is still fundamentally free, and there is a community effort called Adopt OpenJDK, which goes into much more detail. We're looking for contributions all the time. This is about making sure OpenJDK has a place where it can be built outside of a vendor, although many vendors are supporting this effort, Microsoft, Packet, a bunch of other companies. And I'm working with the team in London on some of these things, and we are making sure that OpenJDK binaries, LTSs in particular, like Java 11, are going to be free for a long time. Yeah? So not negging Oracle at all, because I understand commercially why they've done what they've done, but other options are available now. And if you haven't, this is the first time you've heard of this thing, please be aware that, yeah, when Oracle JDK 8 is going end of life, like now, pretty much, and then how you will upgrade may be impacted based on your support options and licenses you have in the company. So check out that kind of stuff if you do run the Oracle JDK. Anyway, back to the main action here. So I often see when I go into organizations, OpenJDK 8 pulled in, and that's what's chucked into production with running a Spring. This is a simple Spring Boot binary I've built there. First off, that is 657 megs. It's like a 20 meg Spring Boot binary that I've got. The rest of it is OS and JDK. Yeah. People often say to me, I've heard of this thing called Alpine, smaller images. Great stuff, loving it. And then they start pinning. We're going to have a JDK version and an Alpine version. Even better. Yeah. Alpine is smaller, faster, less attack surface, and now we're pinning on a known version rather than just 8, which we assume is the latest. Yeah. Even better, though, is not, and I'll just say the size there, we've got a massive size cut already, yeah, from 657 down to 135. You really don't want to be running a JDK in production, though. If you're just running a Java app, you want to be running a JRE only. You don't need the dev tools in production. They're actually a massive security risk, yeah? You just want the JRE. And with that, we get down to 116 megs, yeah? 20 meg of Spring Boot binary, and the rest is pretty much OS and JDK. If you want to go even smaller, Jlink is a new tool to build statically compiled, effectively, binaries of Java. It's pretty new, a couple of books I've been reading. Being honest, I haven't had much luck with it yet, but some of the financial teams I work with are building very compact binaries with just their class and a JRE baked in. No need to install the JRE or the JDK on the box. You simply install this binary and run it. Yeah. It's a nice thing to look at. Same with the Portola project from JDK 12. That's looking at making the Alpine distro even smaller. There's some issue with glibc and muscle, which is a very technical conversation, which I don't fully understand. I haven't got time to go into all the details that I do understand either. But know that 100 megs can definitely be shrunk to about 20 or 40 if we get Portola project working. And it's a community effort at the moment. So check out what's going on there as well. But there is ways, basically what I'm saying, of Java is getting smaller. The runtime's getting smaller. The build artifacts are getting smaller. You know, it's kind of in competition with things like Go and JavaScript. Java is stepping up, yeah? Often questions I get is, why is my image so big, yeah? And the first thing I say to people is, do a sense check. Is it that you've got a massive jar going in, or is it the image itself that's really big, yeah? But if you need to understand a bit more about the actual, the app itself, the dependencies are a good place to start. Excuse me. So I'm using a command here, Maven dependency tree. It basically lists out all the dependencies and transitive dependencies. It's very tempting. I love Spring. Spring is a fantastic framework, but it brings in a whole lot of stuff which can really bloat your jar, yeah? On that note, Maven Dependency Analyze will tell you all the dependencies you're not using, but you are including in the jar, yeah? So these kind of things, maybe I'm doing a really simple hello world. Maybe I don't need the power of Spring Boot. Or maybe I need a very small version of Spring Boot, whatever kind of thing. But just be aware of what you're kind of putting in the Docker image. On that note, if I've written some really, with my teams, I've written some really gnarly Docker files. We had some crazy old Java application that needed, I think, Tomcat and various libraries and tools. It's like a 40-line Docker file, just to do all these weird configs. And it was a massive image, and we were having a hard time understanding what was in this image. There's a fantastic tool that helps there now. Didn't have this at the time, unfortunately, called Dive. Written by Alex Woodman. You basically point it at an image, and it breaks down all the layers on the top there, but you can step through them and see the changes at each layer. Yeah, really nice bit of kit for understanding exactly what's going into your image, what effect each layer is having as you're going through these things. Now, I spun this one up a couple of days ago. This is the Oracle JDK 11 with Oracle Linux involved. You can see the layers at the top there, and you notice, I think that's the base OS, Debian, I think, and then some little bit of config, and then 329 megs there is the JDK, and that's only the symlinks blowing up. but you can look already, wow, I'm bringing in a lot of stuff. Yeah, oops, excuse me, these kind of things. That is a really nice tool for understanding what's going in your image, each layer. Definitely, people ask me, should I be building Java in containers? And I'll be honest, up until a year ago, I was mainly building, teams and I was working on were mainly building using Jenkins or Circle CI, putting the Docker image in a repository and then pulling that down. But I think with the multi-stage stuff that went in last year, it is a genuine game changer. Yeah, the fact now I can spin up my Maven, my fully fat kind of container image with all my tools in. I can add extra tools. I can build, and then I can simply copy the resulting build into my nice lightweight Alpine image. It's really nice. Yeah, really. If you haven't seen this, there's a couple of interesting talks by Thibaut and Sebastian, I think, earlier on. Gareth talked about this stuff quite a lot. I really do like this as a model for keeping everything close together now. My build time definitions, my runtime definitions. Really quite nice. BuildKit is super interesting. Yeah, it takes the sort of what we saw on the previous slide to the next level, and in particular the caching. So if you've tried to build Java apps in Docker, you'll notice the Maven stuff is a real pain sometimes. Yeah, like you change one config and Maven pulls down the whole internet again. You're just like, ugh. And that's always when you got on like an airplane, yeah, or you've got on like a train. It always does that. BuildKit, you can do a whole bunch of clever stuff around where the performance speaks for itself, and you can enable it via this config. But what I'm super interested in is the mount targets. You can basically mount from your host an M2 kind of folder. It's a best effort cache. It's not to be relied on, but it can massively cut down the moving around of all these Maven dependencies. So if you haven't seen it, that was Thibaut and Sebastian's talk. I've forgotten the name, but if you have a look in the program, they talked about these kind of tips. You can find it, and it's this stuff. You have to enable a different syntax in Dockerfile. Well worth doing if you're building Maven jobs or Gradle jobs in a Docker file. One anti-pattern I see in terms of some of the bad stuff is people having different test and prod containers. They create a test version with a fully fat, Ubuntu OS, JDK, all their test tools, in-memory database, all this kind of stuff. And then they have a prod version of the container, completely separate. Yeah. And what they do is they run all their tests in the pipeline in this full fat container, and then at the end they lift out the binary and put it into the production one and ship it. They've tested something really, it's completely different from what they're running in production. Yeah. It's easy to see app configuration drift as well. You update something in the prod Docker file and you forget to update it in the test one, or these kind of things. And I don't know if any people are familiar with the whole gremlin thing. My childhood, I love gremlins, yeah? You don't get the gremlins wet. And basically the kind of analogy I think here is if you have these two Docker files, it's very easy to get one wet and it suddenly morphs into a gremlin, yeah? And it's really hard to debug that kind of stuff. Moving on, so I'm still playing around with this pattern, and probably the Docker folks know more than I do. Well, I'm sure they know more than I do, but I'm trying to learn from them on this. I'm doing these kind of things, playing around with building at the top, having like an integration testing layer where I'm running security scanning and a bunch of other stuff. And then in theory, with BuildKit, I can only target certain stages, so release, and it will build only the stuff that I'm dependent on. Or I can run the whole thing, yeah? So I'm playing around with this kind of stuff. I'm still getting my head around it. Really kind of cool for putting all our config for build, test, and deploy, well, not deploy, but build, test, and creation of an artifact in one file. You're much less likely to see configuration drift if something is very close together, yeah? So this is the kind of thing I'm still playing around with. I should have parameterized, I think, probably the froms there as well, because you should always make sure they're the same. Again, I'm still learning on this, to be honest. Moving on a little bit, so I've cut this section of the talk down a bit because it was the main thing I wanted to talk about in terms of packaging Java artifacts. The main problems I see is in relation to metadata. People simply don't know what's deployed where. Yeah, I take a lot of my cues from Gareth. I'm lucky to live relatively close to him in London, so I get to pick his brains quite a bit, which is quite nice. But Gareth's really altered my thinking, and I've seen a couple of security issues in companies I've been working with, and they simply don't know if they're affected. Yeah, so JDK8's got this vulnerability. Are you running JDK8? I don't know. Yeah, and half the fleet is, half the fleet isn't. Without metadata, it's really hard to understand what is where. And if there is a vulnerability, where do we need to target our effort? So all this kind of stuff. Gareth's done some fantastic talks over the year. And to be honest, he totally stole my thunder in this section, yeah. Gareth and Am did a fantastic job there. I'm really interested around this Docker assemble stuff, yeah. All the stuff that Gareth was showing around, labels the Java dependencies, outputs the JDK that's actually running. This is the stuff that I've been trying to do on and off for a few years. And this new tool from Docker looks like it might be the answer to what I'm trying to get my head around, basically, in terms of if we've got an issue, we can do a query across our metadata store. Oh, we're running JDK 8 in all these things. We're running the dependencies that are vulnerable in these things. Really nice bit of kit. At the moment, I mainly use Microscales Makefile. If I'm in a Git repo, this actually basically puts like my Linux username, Git char, a bunch of other stuff it can pull from the directory and OS, and puts it in as Docker labels. Yeah. So for build time metadata, good to go, I think. Yeah. I often want to add metadata as I'm going along the kind of journey on the pipeline. Have I security checked something? Is it definitely built by us? I want to attest it's definitely been built by us, for example. At the moment, because adding labels to a Docker image and then committing is a bit fiddly, so I mainly use external registries for this kind of stuff. Yeah, JFrog, Nexus, Docker Trusted Registry. Graph.es is super interesting from the Google folk as well. Basically, you need a way of keeping the metadata of your build artifact very close to it. Yeah, and you want to ideally cryptographically sign it. So when we've done our tests, when we've security scanned it, we cryptographically sign that attestation, and we only allow things that have been signed in production. Yeah, and GKE, and GKE, the hosted Kubernetes offering, is doing some really cool stuff in this space, as are Docker with the trusted registry stuff. So there's lots of interesting developments around here. Moving on a little bit, now into the actual kind of testing thing. To be honest, I don't try to be too clever when I'm trying to do tests. I'll literally use Docker Compose or Kubernetes YAML and spin up either namespace or small hosts. And if I'm doing an integration, a big test, I'll often have what I call a test sidecar, which contains things like fake data stores, maybe like Gatling for doing load testing. I have basically an image which I'm curating with all my tools, and I deploy it next to my actual app or a subset of the app, and I just let the tools hammer the thing. Try to keep it pretty simple. I've talked about that in the report, the free reports a bit more, if you want to understand my thinking there. And what I would recommend in terms of picking a few things I want to sort of comment on is definitely, we call them non-functional requirements often. Cross-functional requirements, system quality attributes. We call them non-functional, but I've seen many systems that were not functional due to non-functional requirements, yeah? People have not thought about scalability, not thought about security. These are really important things to verify in your pipeline. I'm going to cover, there's a few links there you can sort of look. I really learned a bunch from Aaron Gratifiore in Seattle a couple of years ago at DockerCon. He did this fantastic talk. He's done a bunch of work with CIS, produced some reports about container security. He talks even faster than I do. It was a crazy fast talk, yeah. And I was like, oh, it's amazing. And I wrote it up for InfoQ. So those are my notes, but Aaron did a fantastic job. It is still my go-to reference for anyone wanting to understand container security, from syscalls up to application level issues, yeah. Really good stuff. Couple of things I've been burnt with in the Java world myself. So basically, the JDK, this is not a Docker thing, it's the JDK itself, or the JVM, is not Docker aware pre-Java 8 update 131. Yes, if you are running an older version of Java, it will look at the host for all of its config, in terms of CPU and memory, and it will configure itself accordingly. Now, Docker will prevent that application from sort of using more resources than it should be able to, but the JVM thinks it's got access to more. And this is particularly troublesome around the get available processors call. So when the JVM spins up, it looks at the host pre-Java 8 and says, oh, I've got, say if you're running a massive box in Amazon, like 72 cores or something, yeah? And it goes, oh, I've got 72 cores, so I'll create 72 threads for garbage collection. I'll create 72 threads for my fork join pool, which is used everywhere in applications, yeah? And you will not get the best performance out of the JVM if you just let it do its thing. You can pass -D command line options to Java, the JVM. It's a bit fiddly, to be honest, but hat tip to OpenJDK folks, the Docker folks. All JDKs after this are aware of things like C groups and namespaces. And in theory, everything gets configured a lot better. So definitely watch this. I've had GC-intensive applications have a real hard time in Docker, old versions of Java. So heads up on that one. Do set your memory requirements. So when Java sort of boots up, the JVM boots up, I think it takes a quarter of the system RAM when it's running in server mode. And again, these kind of things can play a bit funny with some of the Docker stuff. So again, it's Java's fault, so to speak. So check out if you're using older versions of the JVM, older versions of the JDK. And even if you're not, do size your memory. Don't just size it on the heap. A lot of Java developers get very sort of focused, myself included, on the heap size. But the JDK and the JVM needs a whole bunch of other space to load classes and threads and do all these things. So allow an overhead. So I often say 80% heap size to the full container memory. So yeah, that kind of thing. Do be aware, if you've got a very thread-intensive application, which I've seen one I was working on a couple of years ago, threads require native memory, Linux memory, yeah? So I had one, we were getting killed all the time, and we couldn't understand, but it wasn't wasn't Java's fault, it wasn't Docker's fault, but the JDK, or the JVM was spinning up lots of threads, and the OS was looking for memory, trying to instantiate the threads at an operating system level. So all these kind of weird things bite you. You might not have seen them outside of Docker, but they're there. And finally, entropy. I had some really bizarre things where an application would just literally freeze mid-application, sort of mid-run or whatever, and we just couldn't figure it out. And outside of Docker, it was kind of fine, but as soon as we were deploying it into a highly used cluster, it was just freezing. We did some debugging. We basically realized it was halting or freezing on cryptographic operations. Yeah, every time we were doing a security thing, it would freeze. So session generation, a bunch of crypto we were doing in the app, and we're like, why is it freezing on crypto? And we're like, oh, what's happening is because we're deploying loads of Docker containers on this massive Linux box, there's very little entropy. There's no one banging on the keyboard to generate entropy. There's not much network traffic going on. And basically, crypto operations typically in the JVM will call out to dev random on a Linux box. And if there's no entropy, no sort of randomness seed, dev random will block. And that will block the JVM, block your app. Yeah. So what you can do instead, you noticed on my earlier config files, I often do Java security, EGD, and you specify dev urandom. That's a pseudo-random generator. It will never block. Yeah? Now, depending on what you believe, there is some security implications of this, so check it out. There's lots of discussion on this. I don't believe there is an issue now, to be honest, from what I've read, but do check it out. But if you're having Docker, Java apps in Docker that are blocking on crypto operations, on session generations, TLS, whatever, do check out that and pass in a command line option there. Fantastic talk by Max Gillard, goes into much more detail of how the JDK basically has adapted to Docker and other container runtimes. Java was 20 plus years old, yeah, fantastic bit of technology, but it's been a little bit slow to catch up with the container world. Docker has gone so fast and come so far, the rest of the industry has got to catch up a little bit. So the Open JDK folk are doing amazing work, like Oracle and Red Hat, other companies, IBM. But people like Max are sharing these things of, if you're running an old version of the JDK, be aware there might be some issues with Docker. So running to the final bit of the presentation now, I just want to re-emphasize all these things we actually detected, all our weird issues, by just running simple tests, soak tests, long-running tests, nothing crazy. We tried to make our test as production-like as possible. Lots of logins, lots of logouts, hammer the happy paths of the apps, and see what they did in Docker. Well, Java running in Docker. Moving on, final 5 minutes. I want to talk a little bit, some of the mistakes I'm seeing at the moment are around security. I think security is super, super important. I won't mention any names on camera, but you're all familiar with various names floating around at the moment with breaches and hacks, and it's only going to get worse, I think, yeah. At a code level, Java, please do use a static scanner like findbugs. FindSecBugs, sorry. I'm sure many of you have used FindBugs. FindSecBugs is a security module on FindBugs. It will look for things like SQL injection, bad use of randomness, and about 200 other statically detectable patterns in code. You can use it in Maven, you can put it in SonarQube. This is like table stakes for any Java developer. It's all too easy to use uncryptographically secure randomness sometimes. I've seen people do that. This will check for those kind of patterns. Next is Java with Gradle and Maven makes it super easy to bring in many things. Not perhaps as easy as JavaScript, bit of a node dig there, but as in Java, it's still easy to bring in a lot of stuff, yeah? So I highly recommend, in the open source space, OWASP dependency check. Now, OWASP are an open consortium that talk about security. I'm sure many of you have heard of them, the top 10 of vulnerabilities, but they do many other things as well. And literally for a 10-line, maybe a 2-line in Gradle, kind of bit of config, what that does is it looks at the other dependencies I've got included in my POM file, so log4j or whatever, phones out to the National Vulnerability Database and says, oh, I've got a logback file here at 1.4. Is there any known common vulnerabilities and exploits? And if there is, it will fall back and I can fail the build and basically say, oh, this version of my logback has got a known security vulnerability. Yeah? Such a simple include. Cuts down so many things we pull in. We go to Maven Central, we Google or whatever, we pull in all these dependencies. We don't think other people are writing them. They're just like us. We don't always know what we're doing. Yeah? Some people are malicious as well, so watch for these kind of things. I had a 6-month-old app that I wrote. We didn't put it in prod. We were going to put it in prod. I thought, oh, I'll run this on it. And it picked up, I think, 6 vulnerabilities, 6 CVEs. Yeah? And one of them was pretty bad, like runtime injection stuff. So we fixed these, and to be honest, the whole open source world is amazing. All these vulnerabilities, there was updated versions of the library, which we plugged in and we were good to go. Yeah? And we rerun the scanner and it was fun. And then we deployed. There's a nice report to talk about some of it. If you want to show the leadership, show your management to get buy-in, you can say, look, this is what this vulnerability is. It's a high severity, and you can kind of argue your case there. Of course, in the Java world, or I should actually say on the previous one, if you're looking for commercial opportunities, commercial options, because I'm happy to pay for some of this stuff, to be honest, Snyk is a fantastic tool. Loving the Snyk stuff. I'm not connected with them. I just think it's a good tool if you don't want to do this kind of stuff in open source. On the static image scanning, so again, now we're putting our Java artifact into an image, yeah? There's an operating system, there's other tools going on there. Now, obviously, Docker do a fantastic scanning job, and again, I'm more than happy to pay Docker for that kind of stuff. I like them scanning my images, looking for vulnerabilities. Some people want to do open source, so I've used Claire. That came from CoreOS, I guess now Red Hat, I guess now IBM. I think, yeah. But so it's Claire, it's an open source tool. I'm not sure if it's maintained, so I thought about that today. I need to check who's actually maintaining this project. But it's a scanner, you can point at a Docker image and it will look for known vulnerabilities. It used to be a real pain to get running, but Armin, I did this talk a while ago, and Armin reached out to me and said, hey, Daniel, I've created a Docker file, a Docker image that packages up all this Go binary and all this weird stuff. And now you just spin up a Docker image and point it at another Docker image, and you're good to go. You can scan that Docker image. Yeah. So hat tip to Armin, fantastic job. Claire Scanner, I've got the references for you there. You can go on to GitHub. Do check it's still being maintained. I haven't done that for a while. But just an example, this is last year. I literally pulled down, it was the OpenJDK 8 JRE, ran Claire Scanner and found over 100 known CVEs. Yeah. This has been addressed now, I believe, and I think there's one CVE which has a really minimal attack surface, but I'm not trying to poke fun at OpenJDK. It's fantastic work. You can do this with almost any image, and you will find vulnerabilities. Yeah? And again, ignorance is no defense, definitely as a professional. Probably not in the eyes of the law, to be honest, as well. Programmers are getting prosecuted in some situations now in terms of being negligent or otherwise. So even though it's an awkward conversation with leadership often, not knowing is worse. Yeah, so do run these kind of things on all your security, be it dependencies, be it code, be it the Docker image itself. So almost perfect time now, I hope. In summary, so a few things to take away. I genuinely believe Docker and Java are a good match. Yeah, Java 20-year-old tech, Docker 5-year-old tech. But I think now we're learning even more about them. Do make sure you understand the challenges. Any change of deployment fabric will alter your runtime properties. If you deploy to the cloud, everything, all the block stores are on, are basically SANs. Yeah, the way the cloud VMs work is very different than bare metal. These kind of things. Same with Docker. Docker's a fantastic bit of kit, but it does change some of the properties with the operating system, with the actual interfaces. Continuous delivery is essential, I think, for like microservices, serverless, and the technology that supports them. But do remember, make your dev as much like production as possible. Shift left all the security, all this kind of stuff. And what you deploy into production, the container image you deploy into production, should be the single source. Please don't build and test one image and then right at the end, take that binary out and plug it in another image. I understand why people do that, but you really should test along your pipeline using the thing you're going to actually put in production. Provenance, as in metadata, what is going where, is super important. Validation, asserting these cross-functional, these non-functional requirements in builds is vital. Not all developers are operationally aware. You're self-selecting by coming to DockerCon. You want to learn about this stuff properly. But maybe people on your team don't want to, and that's fine. They just want to cut code, yes, what they're good at. But we need to work with them to make them, upskill them in terms of mechanical sympathy and make sure we're running appropriate checks around security and things like that. On that note, I shall say thank you very much for your time.
So do you have any questions?
I've actually got 3 preview copies of my book, 3. If anyone's got a question, I'll happily give you a preview copy, all right? It's not the full book, but...
Hi, hello. First of all, thank you for the talk. I guess my main question, or the main issue we're seeing with Java in containers is like traditional old examples, and one of the reasons containers, right, they're meant to be minimal. I'm not talking about image size, I'm talking about runtime size.
Yes.
And something we struggle to get is containers under 500 megs, right? And
yeah.
it's really hard. We're using Scala, and this is sort of making everything be huge and huge to deploy. Do you have any tips around that, or any magic solution?
I do a lot of Spring Boot, and you almost need a gig to run an image, yeah, to be honest. So there is a bit of a pushback in the Java space with things like Ratpack and about like using Netty under the hood or some kind of event loop under the hood. There is a push towards these micro frameworks. Scala, I think, has got a few. I think Spray or off the top of my head, I can't remember. But the honest answer is you either need to pare back the framework you're using, and the trade-off there is you have to do more of the hard work yourself, or go with these minimal frameworks like Ratpack. I've had quite a bit of success with Ratpack. I think it's like 100 megs to get up and running, kind of thing, depending on what you're doing, so to speak. But it's something to be aware of, for sure.
Thank you.
Cool. Thanks, James.
Any other question?
2 more books. Don't make me carry them home. Oh, I've gone over there. Cool. Oh, can I give you that? Thank you very much. Appreciate that.
Thank you, Daniel, for your talk. It was brilliant. So I would like to touch base about that slide where you were mentioning about mixing up the process of or delegating onto Docker the building of the artifact as a way of creating the image. What are your thoughts about that? Do you think that is mixing what a developer responsibility on creating the artifact is alongside what the ops or the DevOps guy should be,
Yeah, that's actually a very astute observation. And I'm quite happy to get involved with that kind of stuff. A lot of the startups I work with, they're totally like, yeah, show me this stuff. Terraform this, Docker that, Ansible this. They're totally cool with that. Enterprise is not so much. And that's a very interesting discussion. It's probably one over a beer in some ways. It's a long conversation, yeah. I actually think, definitely get developers aware of Docker. Yeah, get them playing around with things. Even if they're not building, just running containers, understanding what's going on under the hood. For the reasons I mentioned, I like including everything close together in config. So my build massively impacts my runtime. So by having it all in one place, I can see what's going in and I can do my tests. But I do appreciate context, as you're alluding to, is really important. And whenever I work with teams, I always look at what our goals are in terms of business and technical goals and what our capabilities are. We have to be honest sometimes. Sometimes I work with people that have only got Scala knowledge, for example, and they don't want to do Java and they don't want to do Opsy stuff. So you've got to very much take the pulse of your team. And if you're like a technical leader, an architect, you've got to weigh in the sort of training budget there. Do I train them more on the Docker stuff? Do I train them more on these things? So I appreciate that's a long-winded answer, but it's something to be aware of. It's very good. Thank you for pointing it out.
Thank you, mate.
What? One more?
It's yours.
I'll give you this at the end, all right? I'll keep for you. One day, thank you.
So I wanted to. Sorry.
Sorry. Sorry.
So I wanted to come back to the first part of the pipeline, so the dev local machine. One of the problem we have, and which is especially true when you are working with microservices, is running all the services on the local machine of the developer becomes quite complex.
Yes.
And if you want to be as close as possible to the production environment.
Yes.
So have you any tips about that?
Yeah. So on that note, just bear with me 1 second. I've uploaded the slides to my slide share, and I didn't include all the slides. So one thing I often talk about is actually Telepresence, and it's not a shameless plug, it's an open source tool I've talked about, and I've actually written an article on very much this problem in the past. Once you, in a microservice system, you really want to create a loosely coupled architecture. So in an ideal world, you'd just be working on one service and you'd mock or you'd stub dependent services, or run an in-memory data store, for example. Or there's things like stubbed Cassandra. If you're running Cassandra, you can stub out Cassandra on these things. But there comes a time, sometime, where you simply need to spin up more things than your laptop can run. Yeah. And then I actually bumped into Telepresence before I worked with DataWire. It is a nice way to proxy into a Kubernetes cluster. And I did a very similar pattern with the notonthehighstreet.com team a couple of years ago, where we had Mesos running, and we spun up Mesos clusters on demand. So me as a developer, I could spin up one on demand, I could deploy services into it, and I could proxy my local machine into that cluster. And the QAs started spinning up their own environments, doing the same thing, proxying in, using all these tests. And that's the best way I've discovered. I always say to teams, loosely couple, try and stub and so forth. This can become a crutch. Yeah, okay? It's very convenient to start doing all your testing on a laptop as if it was in the cluster, yeah, and then only kind of pushing at the pipeline at the end. But I really do like the workflow. I've talked about how I use it a lot when I'm debugging Java services running in Kubernetes, for example. I'm basically proxying traffic to my local machine, IntelliJ, debugging, seeing what's going on, and proxying the traffic back. So those are the two kind of answers I've got at the moment. It's an area where things are changing. I'm learning as much. So if you do have any ideas, I'd love to hear them, to be honest, as well. But those are kind of my thoughts at the current time.
OK, thanks.
Sure.
Any other questions?
Okay. Yeah, at you.
First of all, thanks a lot. It was very useful for me, at least. So one problem that we have, it has to do with like noisy neighbors when a JVM starts, right? Because it will produce a CPU spike.
Yeah, interesting.
And so if, talking about orchestration, if you have a box that runs n containers and it's at 90%, then the start will be delayed. And if it doesn't, then of course we're paying more than we should be paying.
Yeah. Yeah.
So I got a nice idea from you. You mentioned the alternative to that just-in-time compiling.
Yeah.
So the other question is, I just kind of wanted to pick up your brain if you have any other ideas in this area.
Yeah, so that slide I mentioned around AOT versus JIT, because JIT obviously has overhead when it's learning.
Yep.
The trade-off is AOT is probably not as ultimately performant as what JIT will give you. The other thing I mentioned briefly, and it was literally a brain dump, was class data sharing and application data sharing.
Right.
And that, I believe, we mainly do it just for the startup time, but I think it would reduce CPU in that, because when the JVM starts, it looks at your app and it looks at all the dependencies and it kind of loads them into memory. And it parses them. The words I'm using are not quite right. I'm not exactly sure what the words are, but it kind of loads it into memory. With class data sharing, that's targeting the Java classes, the runtime. And with application class data sharing, it's targeting your application. And it basically creates a file that's kind of like a cache of the class. So rather than the JVM having to load and parse all these files, it just looks at the files and loads them in, almost into memory. So I believe that would also reduce CPU time. Yeah, because particularly if you've got a very complicated, heavily dependent app, which is quite common on old apps, there's like massive dependency tree, huge dependency tree. And the way Java builds its kind of class path and so forth is very cumbersome. So I imagine it's probably I/O bound, to be honest, actually. It's probably I/O bound in terms of reading off the disk or the class. I'm honestly not sure on this, but the best I can offer you is AOT is very good. Definitely check out Eclipse OpenJ9. The profiles, again, this is just my anecdotal opinion. OpenJ9 is very good for the cloud. Yeah, it's got a bunch of, I think I might have actually got a slide in it. It's got a bunch of performance characteristics that do lend themselves very nicely, I don't know if I've got it here, to the cloud. Sorry, I thought I probably have got a slide there. But yeah, so default, most people use Hotspot. But the Eclipse OpenJ9, and the way it kind of uses memory and does a bunch of other stuff, I think it's also slightly better for certain use cases with CPU as well. But my caveat would be on this, whatever you do, if you swap out the JVM, please do test like crazy, yeah? Because as much as you get different performance characteristics, you might get other different characteristics. So if you're swapping Hotspot as your kind of runtime to something like OpenJ9 or Substrate VM is really interesting. Substrate VM is Java, JVM written in Java. So Hotspot is in C++ or C. So there's a new thing called Gradle and Substrate. That offers different properties as well. But I'd recommend benchmarking them all, seeing what works for your use case. But those are the things I kind of recommend starting with.
Thank you very much.
Cool, no worries.
We can take the last question, if anyone has.
Then it's time to probably go home, isn't it? Other one more. Thank you, Jim.
Not really a question, but a more generic remark. So in the CD pipeline, it's probably part of the feedback loop you talked about, but I think that observability and monitoring and log centralization is really important.
Agreed.
Because it allows you to get feedback on your application, how it behaves, and how the users are using it, and it gives you also insights for your testing and your load testing on the behavior of your users. So I don't know if you have any suggestions or...
Very well said. So what you said is observability is key for completing the loop. Funny enough, on the previous version of this talk, I had like one slide that basically said the people I look to are Charity Majors and Cindy Shritaran. They both do amazing blogs. So if you're interested in learning more about observability, those are the two people I'd first go and look up. But I completely agree with you. And with 40 minutes, I had to pick and choose. Yeah. And unfortunately, observability was one I kind of dropped. But I completely agree in terms of understanding runtime performance and even like business KPIs and stuff. Yeah, it is really critical. So as the gentleman said, observability, yeah, probably should have mentioned that in the talk, is really, really critical for completing that loop. Observability at the host level, the container level, the app level, and the business levels. Like you really do need to invest to understand how people are actually using your machines, or your apps, sorry. Because you can load test and benchmark everything you like, but users always use your system differently, don't they, as you're trying to allude to. Great comment, thank you.
Yeah, thank you everyone. Have a nice day.